Hi, my name is Feline Hermans. I'm assistant professor at Delft University of Technology. I have a super easy Twitter handle, it's just my first name. So if you're tweeting about this session, do mention me, so it's very easy to look up later if you liked it or what I should improve for a potential new version of this talk. So this talk is about spreadsheets. And many developers think spreadsheets is something out of their view, something they don't have to think about at all. And I'm here to tell you that it's wrong. But it's reasonable that you would think. Spreadsheets are often mislabeled. Many people classify spreadsheets immediately as being data. Spreadsheet is just a piece of data, like a Word file or a CSV file. It's nothing that I should really think about. However, they're really wrong. Spreadsheets are not data. Spreadsheets are code. Spreadsheets are code is sort of the gospel of my life. I do this talk all around the world. I go everywhere and I tell people spreadsheets are code. So if you want to go outside and enjoy the sun or watch your email, that is fine. The rest of the talk is not that important as long as you remember that spreadsheets are code. This is really my main message. I just put it out there in the first 30 seconds because it's really important. It really matters to me. So you might not believe me. That's okay. I have 3 reasons here to convince you that spreadsheets are actually code. First of all, spreadsheets are used for very similar problems. Here you see an investment calculation. You put some data in, a machine runs, and you get the result of your calculation. This is something you can make in any programming language. You could make it in Java, or maybe in an Android app on the iPad and on Objective-C. It doesn't really matter. It's a problem you could attack with any programming language. Of course, you might ask yourself, why would someone do this in a spreadsheet? Why not in a proper programming language? I have thought about this question, and I have asked people, for instance, in an investment bank where I did my research for 2 years, I've asked them, why are you doing this in a spreadsheet? Well, if you don't know this yet, I have news for you. We IT people, we're not that good at making software. So these people that make such spreadsheets, they have gone to their IT, either their IT department or their favorite IT company, and they say, hey, I have this investment calculation. I would really like you to make an app for this or a program for this. Can you do this? Sure, no problem. It will take 6 months and it will be 1 million euro. And if it would have been that, maybe it was fine, but of course they have experienced these types of projects, and then they're 2 million euros, and they're 9 months, and they have half the features they wanted. So bankers, people in insurance companies, in government, they think that they are better programmers than we are. And it's not their hubris only. It's also because, we don't always deliver it. It's true. So that's why many people use spreadsheets. So that's reason 1, used for similar problem spaces. So I go to great lengths to make my point. To such great length, in fact, that I have implemented a Turing machine in spreadsheet formulas to show that spreadsheet formulas are Turing complete. This is it, and I think in addition to being proved that spreadsheet formulas are Turing complete, it's a pretty nice visualization of a Turing machine. So every row is an iteration of the tape, and with conditional formatting, you see the head moving over the Turing tape. It's a pretty nice visualization. If you zoom out, you really see the Turing machine running over the tape. It's pretty cool. And many people on the internet also thought it was pretty cool. Cory Doctorow wrote a little post about it, and it blew up my website because it was on Hacker News. Pretty cool. So I hope I reached a lot of people with my vision. The third reason that spreadsheets are really pieces of programming is they suffer from typical software engineering problems. For instance, only 1 in 3 spreadsheets have documentation. An average spreadsheet is used by 12 different people over an average lifespan of 5 years. Does that sound familiar to you? It's just like source code. It starts out as a little pet project, and before you know it, your whole company is running on this one thing you made, either it's code or it's spreadsheets. So in summary, both the activities that spreadsheets are used for, the complexity and the associated problems, are similar in spreadsheets and source code. But I'm going to go even further than that. Spreadsheets are not just a programming language. Spreadsheets are the next programming language that you all should learn. So again, I have some reasons why spreadsheets are the way to go and resistance is futile. Why are spreadsheets so hip and so in fashion and aligned with everything that's out there? Who knows who made this? Anyone know who made this? From what talk it is? Brad Victor, yes, from Inventing on Principle. So Brad Victor coins the idea of live programming. Here on the right-hand side you have the code of something, in this case a tree. And on the right-hand side, on the left-hand side, immediately you have the instantiation of the code. And if you change something here, for instance, you change a color or you change a parameter, the tree moves instantaneously. And this is something that's very hip, live program. Well, awesome, Brad Victor, we had that in VisiCalc. Spreadsheets are live programming. You update a formula, you get the result. No edit compile cycle needed. So, live programming. Other than being live, which is hip, spreadsheets are also pure functional. If you like programming in Haskell, you might as well programming in Excel, because it is a functional language. Can a spreadsheet formula have side effects? I think not. The only thing a spreadsheet formula can do is take in inputs and calculate results with that input. It's impossible for a formula to update another formula. Purely functional, something that's also back in fashion. So yes, you should learn to program a spreadsheet. Third reason why spreadsheets are useful to learn, everyone knows spreadsheets. Everyone except us. Your next door neighbor probably manages his fantasy football team in a spreadsheet. Your accountant does your taxes with a spreadsheet. Everyone knows how to do a spreadsheet except developers. Isn't that strange? You could say that spreadsheets are the most popular programming paradigm ever to have existed in the history of computing. I don't think there's a paradigm, and if you look at Excel, a tool that has enabled so many people to program, yet we developers say, it's not programming. No, everyone understands it. That cannot be programming. It has to be difficult, otherwise it's not proper programming. Okay, so I'm just going to assume for a second here that you are all convinced that you need to learn about programming in a spreadsheet now. So I have a little example here, selection sort, that I'm going to implement using spreadsheets to show you how powerful they actually are. So I have a list here, and I'm going to apply the selection sort algorithm. Who knows how selection sort works? L1. Okay, I'll explain it. Selection sort is a pretty easy sorting example. You just start at the beginning of the list, you look for the minimum of the list, you take the minimum and you swap it with the first element. And you repeat that. So then you go to the second element, you again look for the minimum, and you swap those two elements. So it's a pretty easy way of sorting. You don't need recursion or anything. You just traverse the list and look for the minimum. So what I added here is just an index row. So this is just the index of all the items I have in my list that needs to be sorted. The first thing I need for selection sort is the minimum. I need to know what the minimum is in order for me to be able to swap it later. And luckily Excel has a built-in function for that. I say I want to have the minimum of this range. I'm going to make it a little bit more fancy. I'm going to use this notation, which is the minimum of the range from the row 3 up to the row 3. This is a syntax that's maybe not that familiar, and I will need this syntax later all the way at the end of the implementation of my algorithm. So I already show it to you here. So I get the minimum of this row. That's 1. Now I also want to know where this minimum is located, because I need to point to that cell in order to be able to swap them. And for that, Excel has a match function. So I'm going to look up this 1 in this range. There we go. It is at index 10. That's correct. Easy enough? So let's start with the basic idea of our implementation. We do it step by step. I use a conditional if here, and initially I'm just going to put a cross, an X, where I'm going to swap, and an underscore where I'm going to do nothing, just to be able to step for step calculate the conditions. So I'm going to say, if our index is equal to the index of the minimum, I'll make a cross there to know that that is the swap spot. So I can take this formula and drag it all the way right. I didn't get any crosses. Who knows what went wrong here? Selection sort expert. What did I do wrong? Yes, indeed. If you take this formula and you drag it down, Excel updates all references. So every reference is relative to the position of the formula. And we don't want that here. We do want to keep this position, but we don't want to keep this position because it needs to stay pointed at the minimum. So indeed, as the gentleman here in the front already said, if we insert a dollar sign and we drag a formula, then we fix the location. And then indeed we get a cross here. And let's also add a dollar sign here because later on we're going to drag the rows down, and then we also need to fix this first index row. There we go. So we have the minimum tied up now. Now we want to have the index position. So as I said, we start at the first position, and this is what we're going to swap with the minimum. So the first index that we're going to swap with is 1. And now we need a function that's somewhat the opposite of the match function we had before. With the match function, we had the value, and we wanted to know the position. Now we have the position, and we want to know the value. So that's an index function, and this might be a little bit counterintuitive, especially to Python programmers, because what's a match in Excel is an index in Python. So what we're going to do here is we're going to look up this value in this range. So we get the first value is 13. Now we can fill out this part of the formula. We have the two crosses. What will happen in case we're not swapping? This is a pretty easy part to fill in. Anyone want to guess what needs to go here? What value do I get in my row if I'm not swapping? Yes, the value above. So that is easy. Oops, that's here. In case this is equal to that one, I'm swapping, so I'm swapping in case of the minimum or in case of the swap value, and otherwise I just take the value from the previous row. So I have the crosses tied down now. I know where I'm going to swap, and the rest of the row will just stay the same. What I do here is I just add some conditional formatting, just like with the Turing machine. So it's easier for me as something like a debugger to see what values that I'm going to swap. So I see now this I'm going to swap and that one. Let's talk about this x first, the first swap value. If E2, so if our index is equal to the swap index, what am I going to put if I'm at the position of the swap value? Anyone? No? The minimum. So if I'm in the position of the swap, that's where I put the minimum. So if I'm in the position of the minimum, that's where I put the swap value. So there are just two values that need to change. If I have found the minimum, there goes the swap value. If I found the swap, there goes the minimum value. So this is our formula, and if we drag it down, again, I made a mistake. Anyone know what went wrong now?
The minimum is not updated.
Yes, you see the minimum is not updated. So in our initial row, we just had the minimum of the entire row. That was fine. But for the next one, I shouldn't found that one. I should actually start here. And Excel has a very nice function for that called offset. It takes a range and it moves the range through the spreadsheet. So if I take this range and push it further every step, then I will just get the minimum of the part of the array, the row, that is not sorted yet. So I can take this value as the offset. So initially, I don't offset at all, and here I offset 1, and here I offset 2. Ta 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 ta! Selection sort in a spreadsheet. Isn't that nice? But you might say, well, I don't really like to read all these cell references. That doesn't look like programming. It needs to be a bit more ununderstandable, or maybe understandable. It needs to look more like programming. So, okay, I got you covered, but we need to go a little bit deeper into the scariness that Excel has to offer. So here's a piece of specifically cryptic syntax in Excel. Does anyone have any clue what this means? So it's a range, a space, and another range. Yes! Dang, 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 a t-shirt for someone over there. It means intersection. So if you click it, you sort of get help from Excel. You see that this value. Why Excel? Why a space? Why not just intersect with two arguments? I don't know. I wrote a parser for spreadsheet formulas. Do you understand how hard it is if spaces have meaning? Why? I don't understand. But, well, you can make nice formulas with. Oh, a question.
Which language do you write the parser?
We used Irony. That's a parser generator framework in C#.
You did write it in a spreadsheet.
No, I did not write it in a spreadsheet. Okay, so we can use this intersect to make our formula a little bit nicer. And we're going to use named ranges as well. So I'm going to name this range index. And what I can do now is I can take the intersect of this index range and the column I'm currently in. That looks like this. So instead of pointing directly to that E2, I'm going to say what I want is the intersection of the index row and the current column. And now this E column is optional. I can drop it and I still have the same functionality. So what I say now here is if the intersection of the column that I'm currently in and the top row is equal to D4, then the rest of the formula happens. And I can repeat this trick by naming these ranges also, and then I get this. Isn't that almost readable? If the index is equal to the index of the minimum, take the swap. And if the index is equal to the index of the swap, take the minimum. And E3, something with E3. That needs to go, don't you think? I'm almost there. It almost is like a programming language apart from that E3. And it's not so easy to change that because in contrast with the other ranges that are fixed, I'm constantly pointing to something in the first 4 columns or in the first row, this goes down all the time. And of course I could point to it, but I want to have the same formula for all these values because that will be better to maintain and also it will look nicer. So we need to go a little bit deeper even in what exactly you can do with named ranges. So this is something we already saw. We can make a named range, let's call it all you need, and we can have a range that points to a value. This is very much like the minimum. So you just say this cell or this range gets a name. Something like these are all my customers or these are all my products. But we can play with this. It doesn't have to be a range or a cell. We can also put a constant in there. So you can say all you need is love. And then you can use to it. Look at that. All you need is love. Love is all you need. Isn't that nice? It doesn't need to be a named range. It can be a named love, a named constant. But we can go a little bit further. And because I really like music, apart from spreadsheets, let's take a few other songs that I like and try to name rangeify them. So here's a song, really beautiful song. However much I love you, you will always love me more. This needs to go in a spreadsheet. It's poetry. So again, like with all you need is love, I can use a named range. I can put a constant in. So I can say my love is 15. I hope my boyfriend thinks that's enough. So what I can do now is I can define your love based on my love. It needs to be more. However much I will always have more. Your love is, so what I can do is 1.3 times my love. So I can put a formula in the named range. That depends on the named range. Ta 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 ta. Doesn't work in the case of 0. Doesn't work in the case. It's just multiplication. It will work. Maybe it wouldn't run. The test wouldn't pass, but it will work. Okay, let's go a little bit more than that. Every day I love you more. So this is a little bit more complicated. In the case I love you more, and it's just 1. But now every day it needs to be more. So we need to have more complex construction. So let's start at 15 again. And what we can do is use the row function, and you can put a cell in here. So for instance, if I would do the row of B3, then you get 3, and the row of C10 would be 10. But I can also use it without arguments. Again, parser nightmare. There's only a few formulas that do not use arguments. Why? But it's how it works. So you get the row of the current formula that you're in. And this, in a sense, is also such a dynamic formula that is the same formula, but calculates something different based on where it is. So we can use that, and we can make a function a name change that points to the cell right above us. So what we do here is we make a cell address of the row that's one higher and the same column. And that looks like this. So now yesterday's love is C4. So we're somewhat close because we now have the name of the cell above us. But we don't want the name, we want to have the value, we want to refer that. Excel has got you covered as well, because there's a function that's called indirect. And what does do, it's most likely maybe to the eval in JavaScript. You put a string in and then you get whatever the string evaluates to. So you put a string in, B3, and what you get is the result, the cell reference to B3. So this one is equal to that one. Intuitively, you just throw away the brackets and you throw away the quotes. You make a reference from a string. So we can use that here. So we can say instead of this string that we have created with a reference, we make a reference to that string. So now we have the value in the cell above. And if we drag it down, it would always point to one cell higher. So the only thing we now need to add is the Van Buren factor. This is the amount of love that you get more every day. So we can just say today's love is yesterday's love times an arbitrary factor. Done. So now we have a formula in the name range that depends on the cell above it. So it's almost like we've created a method with a lot of hassle that you can put something into the cell above and you can use it everywhere. Oh yeah, what were we doing again? We were getting rid of that nasty E3. That's what we came here. I was not here for the love, I was here for the selection sort. So we can use everything I showed you before to get rid of that ugly, nasty E3 that's standing in between me and a nice spreadsheet program. Because what I can do is I can, in the similar way that I was pointing to yesterday's love, I can make a name change that's pointing to the cell, the row right above me. And then I get the intersection of the row above me in a similar way as we got the intersection of this index and the intersection of the columns. So I'm just going to say an indirect, make a reference from a string of the row above me and another times the row above me. This is what I showed you all the way in the beginning, that minimum of 3, semicolon 3, when I said I'm going to need this all the way at the end. This is the end of the algorithm. So what do we have now? It reads like a novel, doesn't it? If index is index minimum, then you get swap. And if index is index swap, you get minimum. And otherwise, you just get the previous row. So for comparison, to convince those of you that are still in doubt, I also made selection sort in Python. So what's nicer? I don't know. I'm a neutral observer here, but you could argue that this is more concise if you really wanted to. So you could now say, well, Missy, obviously you put a lot of thought into coming up with one example for which it's arguably somewhat easy to use a spreadsheet. Yeah, you would be very right. It took me lots of effort to come up with one example. And sometimes when you're not looking for wonderful answers, all of a sudden they hit you. So some people might have seen this talk already on the internet because I've done it a bunch of times before. This is actually new stuff, hot, just in from last Saturday. This is me last Saturday. I was on a hacking weekend with some of my friends. We do this every year. We rent a bungalow and we go there with a bunch of programmers and we do whatever we want to. So together with Cheered Hans, that's this guy, we decided to participate in a programming contest. And really, I didn't go there to Spreadsheet. It was Saturday, so I was off. I was just going to do some hacking with friends. So we thought, okay, let's use F# because he knew Haskell and he wanted to get into F#. And functional programming is usually a really nice way to look at algorithmic challenges. So these type of puzzles that we were doing were puzzles from the Euler project, which are numerical math programs. So we just started in Haskell. Oh, and we started in F# because it was easy. But after a while, I had this itch. Like, I think I know something better to do this with. Maybe, I'm a bit afraid to say it, maybe we can use a spreadsheet for some numerical math problems. So I have some examples. I just did this, during the previous session, so it's not as polished as the rest, but it was so nice that I really wanted to share it with you. So what you see here is Pascal's triangle. One of the exercises in the programming contest was we needed to get give the sum of the 100th row of Pascal's triangle. So it turns out you can do this just with two spreadsheet formulas. You start here with a 1, and this column only has a reference to the previous column, so it's just all ones. Why, Apple? I'm sorry I'm running Windows on a MacBook, go away. So this is just all ones, and this formula is just the sum of the previous two. And all of this is just this one formula dragged down. And because it was just a one-time throwaway solution, I didn't do all my named ranges magic, so maybe in 3 weeks I won't know what's there. But it was just two formulas. This is copied down, and this is the sum. And that easily, you just drag it down to the 1000th line, maybe 2 minutes, it has to calculate everything, and you get your results. Pretty easy. So I went to Rosetta Stone. This is a really nice website that has a bunch of these type of problems and shows them in many different programming languages. So if you go there to Rosetta's code, this is the C program. Oh. And this is the F# program. It's not that easy to do it with another programming language. Plus, if you do it in Excel, you have the added benefit that it's super easy to inspect a value. If you have the feeling that something is wrong, you don't have to do printf debugging or TDD. You just click the value and you say, oh, what's there? So maybe it's not perfect for solutions that you want to use often, but for this type of prototyping problems, it's really nice that you have your code and your data together. And it wasn't just Pascal's triangle. Here was another program that we needed to do. This is a triangle optimization problem. So you are walking through a maze, and you have to collect the highest number of points. And for those of you who know what it is, it's a dynamic programming problem. It's a famous example of optimization problems. So you can just do that with one spreadsheet formula. Again, you have all your inputs, and you just use one spreadsheet formula. And if you compare that again to the C variant and the Haskell variant, I don't know what's easier. It's pretty nice that you can do it with one formula and just drag it down. So maybe I should have not thought very hard and deep about my initial problem, but just looked at some of these programming contest examples, because this is actually where Excel shines in these simple numeric examples. Okay, so if spreadsheets are programming, and I'm just again going to assume that all of you agree with me that spreadsheets are programming, could we make spreadsheets maybe somewhat better? Could we have spreadsheets and spreadsheets users benefit from all that we have learned in software engineering? And this is the core of my research. This was actually the core research question of my PhD dissertation. Can we apply software engineering methods to spreadsheets? This is it. This is my dissertation. Isn't that cool? I'm still very proud of it. So the answer to the research question was, yes, we can. It's actually pretty easy to build IDE-like features that we have in programming environments, into spreadsheets. And users can work with them and actually make their spreadsheets easier and more robust. So I'm going to briefly show you two examples of the research that I have been doing at Delft University of Technology for the past 7 years now. So one of the tools that we've built is called Bumblebee, and it's a refactoring tool for spreadsheets. So it looks like this. If you have a spreadsheet, you get an additional tab in the ribbon that helps you optimize, make your spreadsheet formulas easier to read. So here's an example. For instance, a user has used a sum divided by a count. Well, you could do that a little bit easier. You could use an average, and your formula would be half as long. And these type of formulas, we encounter them often. So either the user didn't know that there was a built-in average function or a built-in sum if function, or over time the formulas have evolved. It used to be a sum, and then someone thought, oh no, I need to make an average of it, I need to divide it by the count. So you see these formulas, they grow longer and longer like source code, and at one point you think, maybe we could do it a little bit easier. So what you can do with our plugin is you can find rewrites, refactorings, to apply to your formula, and in an automatic fashion, you can click, say, apply in range, and your formula is refactored. And this is a slightly older version of the tool than we have it now. What we now even have is, if we apply a refactoring, we look at the current input, and we make sure that the value doesn't change. So if you accidentally make a refactoring that changes something, at least given the current input, you get a warning. And this is something we want to elaborate on, to check for multiple types of input if your formula is probably behavior preserving. And these transformations are programmable with a little spreadsheet-like language. So we put a number of default refactorings in, but you could also imagine that you're migrating a spreadsheet. You want to change a business rule, and you can use such a rewrite also to update an entire spreadsheet where your interest used to be, I don't know, the number of customers divided by 513, and now you're going to the number of products times 2. You can easily implement such an update as well. And we haven't tested this language yet with users, but we imagine that those type of power users that can do VBA programming could also define these type of rewrites to apply on the spreadsheets. If you want to play with it, you can download Bumblebee from my website, and it's Excel only, but you can try it and you can maybe make your own rules and apply them to your spreadsheets. And of course, if you say refactoring, this is an easy one, people. I know it's late, but if you say refactoring, you say testing. Oh, I'm so happy someone said it. If you say refactoring, you say testing. You don't want to go refactor something if you're not sure that everything won't change. And even though we can run the current input or a few hypothetical inputs, what you really want to know is, are my tests not failing? And we actually implemented it in this fashion. So first we did the refactoring tool, and then we did the testing tool, because we thought, well, it's very hard to get end users, normal people, to test. It's already pretty hard to get developers to test. How are we going to convince spreadsheet users to write tests for their spreadsheet? And this was a classic ivory tower mistake. I was assuming that people couldn't do it. I didn't look into it really. I just assumed, this is too hard. They won't get it. I'm sorry. Because if you actually look at people, you see that they're pretty good at testing. These type of formulas are pretty common in spreadsheets. So it's really poor man's testing. If the sum of these cells does not add up to 100, then I just output error. And otherwise I output OK. Or otherwise I output 100%. So because there's no JUnit or NUnit for spreadsheets, what tools do spreadsheet users have? Spreadsheet formulas. But they do this. And of course we can exploit these type of formulas. Oh, you already know what testing is. You already have a test suite. Let us gather these tests, put them into a test suite for you, and put them to work. So we made another tool called Expector that can extract these type of tests from your spreadsheet. So you can click Find Existing Tests in the spreadsheet, and you get a pop-up saying, well, we've analyzed your formulas, and we do this heuristically. So we look at words like OK, error. We even encountered saddy and smiley faces as a result of these test formulas in real-life spreadsheets. So we say, OK, it looks like this D10 is a test formula, and it expresses that this sum should be 100%. And it does that by looking at a list of passing and failing words. And then you can run them. So as soon as you've saved them, we put in an extra worksheet that's normally hidden for the user. And then you can run your test. So you can say, well, you have one test and it has passed because it is 100%. And if you're more of a visual type of person, you can also color your tests where you make the passing ones green and the failing ones red. And then, of course, if you have a test suite, you can start doing wonderful things like calculating coverage. So the user can say, show me what is tested. Well, these cells are being tested because we say this is a test, and these cells are covered by the test. Because if something is wrong in the input of the sum, it will show up here. So we consider this tested as well because any failure here will result in a failure there. So we don't do complicated things yet like branch coverage or statement coverage. We just have a simple cell coverage model where all tests and all their precedents are considered tested. This is something we might want to refine in the future, maybe make it less yellow if it's farther away from the test, but this is all still experimental. We don't know if users really understand in a route like that. And then, if you have your test suite, so we try to warm up people easily. We start with, okay, you know, this is a test you wrote yourself. We put it in a test suite. You can run it. You can get coverage. Still with us? Okay. Maybe you want to add some more tests now. And we don't do that randomly, so you can pick either testing a complex formula, a formula with a high value, or a formula that has lots of precedence. So you click the button, you get one suggestion. Here's one formula that you should test if you only have 5 minutes. So something like this. This is a formula, it's two nested ifs, conditional complexity. That's something you might want to test because it looks like something could go wrong there. So we say, well, here's a test here's a formula that you could add a test for because it looks very complex. And if a user wants to make tests, he gets a few default options. So you can either test the type, so you can say it should be a number or a text, or it shouldn't be a number, or it should never be empty, or you can set upper and lower bounds. So still pretty easy things that you can do, but again, we want to make it as easy as possible for people to do this. And then you get like a sticker. Wonderful, you've increased your coverage from 6 to 8%. Way to go. Maybe we should add happy smiley face there as well. And now you see your test set has grown because in addition to the test you already had, you now have also added these tests that it should be bigger than 0 and it should be smaller than 1. So you see your test set grow. And if you would click again, show me what's tested, you would see that that cell would now be yellow as well. So we're trying to softly, slowly convince users of spreadsheets to make their software products more robust. Also available from my website. And I can imagine that if you're in a process, and I know this is common, where you have made or your customer has made a spreadsheet prototype, you can have the user add tests before you do the migration project. Because then you know what tests you should have in a new project. You know what assumptions users have. So we also think that this is a product that's not just going to support spreadsheet users that want to stay in spreadsheets, but is also going to support migration projects where there is already a spreadsheet, but you want to get out of it eventually because you want to add things like logging and authorization and all that stuff that you wouldn't necessarily have in a spreadsheet. So this is a tool mainly aimed at end users, but could also be very useful for developers involved in these type of projects. So I think I have a few minutes left for questions. What I'm going to do is I'm going to summarize my entire talk in 1 minute. If you haven't been listening, you watched outside or you did your email, that's okay. But this is your second chance to still get the gist of the talk. And if you were there all along, then of course this is optimal preparation for question asking. So once more, spreadsheets are code. That's all you need to know. It's really important. Why? They're used for similar problems. They're just as powerful, and they suffer from typical software engineering problems. They're not just a programming language. They're super hip, they're live, and they're functional, and everyone knows how to use them. So what we did at Delft University of Technology, I showed you selection sort in a spreadsheet, and also these other things that I didn't put in my overview yet. Spreadsheets are code, so we can apply methods from software engineering to them. So what we did at Delft University of Technology is we built tools for refactoring spreadsheets, for testing spreadsheets, to make spreadsheets more robust. If you want to know more, you can go to my website. I already showed it to you before, where you can download my tools. You can also have a look at the website of my research lab, where I force grad students to also like this. And if you want to know even more, you can send me a tweet or send me an email, or talk with me tonight or tomorrow. I'm here at all conference, or ask a question now. That's totally okay as well. Any questions? Yes?
Do you feel like lots of business problems relate to this format of having like a two-dimensional table? Because I know that lots of business people think in that way because they're used to it, but do you think that is a representation of the actual problems that they're facing?
Yeah, that's a very interesting question. does your language shape your thinking, or does your thinking shape your language? I think that's sort of an unsolved problem. It's a very good question, but I wouldn't have an answer. I do think, I mean, like thinking about it backwards, it's so popular. Probably the cognitive distance between how people think about their problem and how they can do it in a spreadsheet is not that big, or it wouldn't have been so popular. But that's not proof, that's just observing. Okay, one more.
Have you, in your research, ever looked at changing the way that spreadsheets work to make them more compatible with the more complicated things you're doing, or is it just looking at Excel?
Yeah, so the question is, have we looked at alternatives to Excel or alternatives to the spreadsheet paradigm? That was actually my initial research plan. So my earlier work is about extracting class diagrams and extracting data flow diagrams from spreadsheets in order to re-implement them, or in order to build another language, a smaller language maybe, based on what was in the spreadsheets. But that met a lot of resistance. People really, really, really like spreadsheets. And there have been other alternatives as well. I know there's a research group in Oregon that has tried forever, since the 90s, to add a type system to spreadsheet. They built their own spreadsheet engine that has types. So you cannot add dollars to euros or something. That's super useful. I applaud that. However, it hasn't made it into either Excel, or people haven't moved to that platform. So my approach was just, we've tried all these things, it's very hard, why don't we do it the other way around and bring tools we know that make the same problem better? Why don't we bring them to spreadsheets? Because the situation, not that I was there, but the situation in the 70s and 80s in software was pretty similar. People made something for themselves, and a year or 5 later, it was still there, and the compiler was lost, and there was no documentation, and we didn't have refactoring tools, we didn't have testing tools, it was one big mess. So we made these tools, refactoring tools and testing tools, and, well, let's not consider the problem solved, but at least we've become better at making software. Why not help users do the same if you can do it in a way like I'm trying? Not to give them, of course, Eclipse, because that's not helping, but take little pieces of it and massage it into something that fits their frame. But that's sort of a philosophical question. Should you look at what people want and give it to them, or should you say, no, you're doing it wrong and here's a better tool? We can debate on that for hours, I guess. No more questions? Thanks!